let's talk about the transformations of logarithms. Now, again, your vertical translation is still going to add or subtract on the end. Okay, that's going to be the same, but the horizontal translation will once again happen in parentheses. So all you have to do is look for those parentheses to see that left and right movement. Okay, your reflection, if you're going to reflect over the y, once again, that will be in parentheses. And the reflect over the x will be the very first negative that you see. Your horizontal stretch or shrink will be in parentheses. That's our comfort place. It's where it is in a lot of functions, so that's great that it's back for logarithm. Whereas your vertical stretch and compress will be at the very front, as it always was. So that being in our head, let's look at some graphs. So we're going to do the common log first. It's called common log because the base is 10 and the base is understood to be 10. Now logarithms are one of those functions it's very hard to graph all of them by hand. So I'm going to do a lot of this on the calculator and then I'm going to be sketching a lot of it just onto my paper, okay? Now this is the original function, so I want to graph the original so we can kind of go back over the way that these look. So let me get these off of here, great. And I'm going to graph log base 10. This is the common log, so you can use the button that's right next to the 7. So I have log of x, and I can graph that. Remember, there is a tail that goes down. It's just not going to show up on your calculator. The interesting point that you're going to see on the original is going to be this point here. It's going to be 1, 0, which is not a surprise because remember when we did just a regular exponential function, we have the point 0, 1 as in our graph, and so the inverse of that would be 1, 0. So that is there, and then I'm going to, that's not what I wanted. Did I grab a different calculator? Yes, I did. This is the calculator. Sorry, guys. So anyway, we're going to graph this up. And so it kind of comes up, I'm just going to kind of sketch it out. Looks a little bit like this. And then I have hang on. My screen did a weird thing, and I don't know what it did. Oh, okay, it's back now. Okay, so, and I have an asymptote here. And that has a vertical asymptote, and that vertical asymptote's on the y-axis. So the vertical asymptote is going to be at x equals 0. Now what I want to do is take the logarithmic function and I want to do some transformations. Notice there's a negative inside the parentheses. So this first transformation, I'm going to write them down here. That first transformation for g of x is going to be a reflection over the y-axis. And then I have a 1/2 in front of that x, but it's all in parentheses. So that would be a horizontal stretch by a factor of 2. All right. Now let me show you what that looks like. So we're going to go back to y equals and put that one in. So I still have log base 10 of negative 1/2 x. Notice as I typed this in the calculator, I also put negative 1/2 x in parentheses. So you're going to see that reflection over the x-axis, boop, like so. Notice that y-intercept stays the same, okay? Is it the y-intercept? Not the y-intercept. And it's not. Look at the x-intercept. The x-intercept actually goes over 2. So I'm going to notate that. I'm going to notate that in here, okay? You want to notate your intercepts if you can. All right, so it goes here, then it kind of reflects down. Now, the calculator is not going to show you this, but the tail does go all the way down. Notice that the asymptote did not change. Let's see what would have to happen for the asymptote to change, okay? So here, I have log base 1/2 of x. You can put that in your calculator. If you do, you're going to find out that it still has an x-intercept of 1, I think. Okay, I forgot what function we were doing. All right, so this one is the reflection of decay. So it does still have the x-intercept of 1, but now it swoops down this way and up this way. So this is my f of x. Notice once again that the asymptote is on the y-axis. So, and since it's on the y-axis, we would say that there was a vertical asymptote at x equals 0. Then we're going to do some transformations. Well, the first transformation I see is a 2 in the front. So that's going to be a vertical stretch. And then, oh, by a factor of 2, excuse me, by a factor of 2. Then I have an x plus 4 here in parentheses. So that's going to be a horizontal translation. And that one's going to go left 4, okay? So when you graph this one, so I'm going to do math, and I'm going to go all the way down to option A so that I can change the base. My base is 1/2. And in parentheses now I have x plus 4. So you can see a little bit of that vertical stretch, and you can see that the x-intercept has moved over 4. 1, 2, 3, 4 steps. And because of that move, you'll also see that the asymptote has moved. So the asymptote now will be right here where x is equal to -4. And that would be because the asymptote was shifted left 4. So because the whole function was shifted left 4. So make note of any asymptote changes and try your best to make note of any x-intercepts for your logarithmic functions. Very quickly, I have about 2 minutes. So let the graph of g be a reflection in the x-axis followed by a translation 4 units right of this graph, f of x equals 2 to the power of x. Write a rule for g. Now you are more than welcome to sketch these graphs in your notes, and I would strongly encourage it, but I'm very much out of time, so I'm going to move very quickly. All right, so my original is right here. I'd like there to be a reflection in the x-axis. To do that, I have to have a negative smack in the front. And I'd like to go 4 units right. That has to be in the exponent. So in the exponent, I'm going to have x minus 4. Ooh, that was the bell. Really quickly, example 6, here we go. Let the graph of g be translated 2 units up, followed by a vertical stretch by a factor of 2 for this logarithmic graph. Write a rule for g. So g of x, I'm going to keep my base. I know it's going to be log base 1/3. I just need to add these other things in here. So I have a translation 2 units up. To go up, I just add a 2 right on the end of the original. This is the original. And then I need a vertical stretch by a factor of 2. A vertical stretch goes in the front. And that's all you have to do. And that's your lesson on logarithms.